Hello, my name is Andy Schweitzer, and this is a short video on salts, the acidic or basic properties of salts. The first question we're looking at here is, what is a salt? Now, a salt has changed over the course of time as far as what it is, or how they define what it is. So, a salt in the old days was an acid plus a base would yield a salt and water. This is the old definition. So a salt would be defined as the proper product of an acid-base reaction. Your most common example of this would be HCl plus NaOH would yield NaCl plus H2O. I don't have to have NaCl being produced. This is the most common salt, commonly referred to as table salt. But I could have used HF as an acid and NaOH and produce NaF as my salt, and then my water would be here. Pretty simple. I have a cation, an anion, cation, anion, cation, anion, and it's just a simple rearrangements of cations and anions to form the new option. And water. Neutralization reaction. Sometimes referred as a double displacement, although I don't like that terminology. Either way, a salt is a product of a neutralization reaction. Now that's the old definition. The new definition would simply call a salt an ionic compound. Any ionic compound is a salt. We use salts all over society to do lots of things for us. But anyways, next thing is, how does a salt produce acidic or basic solutions? So, for example, is NaCl, is it an acid? Is it a base? Or is it neutral? Or let's say NaF. Is it acidic? Is it basic? Or is it neutral? And I'll walk through a couple things here, and some of it gets a little more in depth than others. I'll try to clarify which stuff is the most important. But in some sense, if it's going to be acidic, it will have to, in the end, produce H3O plus ions. If it's basic, in the end, it will have to produce hydroxide ions. That goes for anything that is acidic or basic. So, in general, we have a salt. Let's just call it X and Y. It's down here. Okay, let's go with substance salt ion compound XY. This is the cation, this is the anion. How would this particular salt be acidic or basic? Well, the answer is going to be what's called hydrolysis. Okay, hydro and lysis means to split. So for this purpose, let's see if I get more room here. There we go. We have our cation, and it will undergo this chemical reaction. Now this part is a little more in depth than maybe you have to have. H plus, I'm going to say, erase that 1 second. Got a little ahead of myself. Okay, and that's fine. Erase that. Now, the cation, X negative, X positive, will react with water. Okay, and the water molecule looks like this. Okay, it's positive, it's going to corral or split water right here and take an OH for itself. And there's the water molecule, it's splitting, and it's going to produce XOH. And then it leaves the H plus to fend for itself. Again, this is the same thing. This will jump onto a water molecule nearby and form H3O plus. So H plus or H3O plus, we're saying it's the same thing. Therefore, the cation, with hydrolysis as a reaction pathway or means, has the ability to be acidic. The anion, Y negative, When it does the same thing, plus water, we'll do just the opposite, or do it a little bit different. It will react, get my marker back, it will react with the water molecule, and it's going to split. It's negative, so it wants to grab a positive H right here to form HY, positive, minus, and leaving the hydroxide behind. Now these problems can get more, I can go more into depth. That would show a little bit more complexity of this, but at this point I'm okay with the level we're at. Okay. Cations have the ability to be acidic if they can split a water molecule. Not all cations can. If they can't, they would just be neutral. Neutral cation. This guy has the ability to be basic. Okay. So how do I know if a salt produces acidic or basic solutions? Okay. The next part is how do I determine it, but this is how it actually works. And every single salt has a few ways you could classify it. The salt, cation, anion. Okay. The cation has the ability to be acidic, and the anion has the ability to be basic. If that is the case for both of them, my salt will cancel to being approximately neutral. So let's walk through the options. I could have an acidic cation and a neutral anion. I would have a weakly acidic. Salts will never be strongly acidic or strongly basic. If I have a neutral cation, I could have a weakly basic anion, giving me a weakly basic salt, or they both could be neutral, giving me a neutral salt. Okay, so I have a couple of options here as far as possibilities for my salt. Next slide says, okay, how do I determine which a salt is of this option? And I'm going to walk through a couple examples here, and that way it'll take a little longer, but eventually you'll be able to jump through the hoops pretty quickly. Okay. First, a few things you need to know about before you solve this is that there are 6 strong acids. Okay, that's going to be HCl, HBr, HI, HNO3, H2SO4, and HClO4. Now, strong bases. Okay, to get a strong base is mostly a very soluble hydroxide of a very strong hydroxide ionic compound. So, for example, potassium and sodium are extremely soluble. So we have potassium hydroxide and sodium hydroxide. They are very soluble, therefore they're considered strong bases. But in general, we take the periodic table and it looks like this. And anytime you take a metal from the first 2 rows, columns, and you add a hydroxide to it, we're going to consider that somewhat soluble enough to produce enough base to consider it to be strong. So any of these 2 here, whether it's a first family or second family hooked up to hydroxide, that's considered strong. So for example, iron hydroxide, put a 2 here, is not considered strong because it is not soluble enough, but it also, iron is not located in the first 2 families. It's in the middle here. Alright, so now, one thing you should also understand is that in a chemical reaction, we have, let's say HX plus water yields X. Let's go. This guy's going to it's going to be negative, and then we have H3O plus. Okay, so this is my acid. It's going to donate to my water here to produce this guy here and this guy here. So this is my acid. This is called my conjugate base, and this is called my base. This is my conjugate acid. Okay, you need to understand that if you're an acid on one side, your conjugate flips around to a base, or your base flips around to your acid. Either way. You can't be an acid on both sides. You can't be a base on both sides. You flip. Once you have the H, you are considered the acid. Once you get rid of it, you're considered the base, which is an acceptor. So you go from having it to not having it. So, from all of this, we should know that a strong acid, its conjugate is going to be neutral. A strong base, its conjugate is going to be neutral. A weak acid, its conjugate will be a weak base. Back and forth. So, when I look at a salt, like let's say, for example, NaCl, okay, how do I go about actually determining whether NaCl is acidic, basic, or neutral? Keep in mind a few things that I've mentioned here already. Okay, this is how I do it. I take an acid plus a base yields a salt and water. Well, I produce this reaction by switching up cations. So NaOH, this is +1, -1, and the water is going to be, I'm going to use HOH as my option, +1, -1. And then I'm going to reverse this reaction to figure out what salt and acid base put together to produce this. So go from Na, just reverse the process. OH, NaOH produced this, is my base, NaOH, and then my acid was H. And I made a small goof here, just so I don't keep it going. I wrote down NaOH, and I wanted to write down salt. So let's get rid of this guy here. Alright. And let's put in the actual salt, which is going to be NaCl. Okay, so NaOH is my base, HCl is my acid. Now, are these strong or weak? Well, you should note that this is one of my 6 strong acids. So put strong here, and therefore its conjugate, which goes to here, the chloride, and both of my conjugates go to the salt. This is going to be a neutral anion because it comes from a strong acid. Strong acids produce neutral. NaOH, well, I mentioned very soluble. Na is in the first family, so this is also going to be a strong base. Therefore, its conjugate, which goes to here, is going to be also neutral. So I have a neutral cation, neutral anion. Therefore, this is going to be a neutral salt. I went through lots of stuff here, but we can go much quicker as we move on. Let's try, for example, the salt I had in my other example was NaF. Alright, I have HOH producing my acid, my base, NaOH and HF. This is a strong base, this is a weak acid. Therefore, the NaOH is neutral, and weak acid will produce a weak base. Remember, the cation has the ability to be acidic, anion has the ability to be basic. This salt, therefore, is weakly basic. As you go through, you'll find that these particular substances get easier and easier to classify. Okay. We'll stop there at that moment. This is a simple video on how to classify a salt and determine its acidity.